This is the first lesson of indefinite integral. Obviously, the nature of today's lesson would be very simple, and all the functions that we'll face are directly solvable by the table of integrals, or you need to change them slightly, the functions, to be usable by the table of integrals. Okay, let's start with an easy example. So e to the power of 2x minus 3 over 2x minus 1 plus 3x 4 dx. So if you look at the table of integrals that I shared with you already, you will see such formulas there. So 1 over a e to the power of ax plus c. Also dx over ax plus b equals 1 over a ln absolute value ax plus b plus c. And finally, integral of x to the power of n dx equals 1 over n plus 1 x to the power of n plus 1 plus c when n can't be negative 1. Okay, if you look at these formulas, taking the integral wouldn't be a problem because all of them are actually in correspondent to those formulas. Now I'm going to erase those arrows and let's take the integral. So the first one would be 1/2 e to the power of 2x. The next one would be 3 over 2 ln absolute value 2x minus 1. And finally 3 over 5 x to the power of 5 plus c. And we are done with this question. In the next example, if you look at the function under integral, you can't see it exactly in the table. However, by very slightly changing it, you should be able to refer that to one of the formulas in the table of integral. So let's start with this one. So the only change that this function requires is writing it as x to the power of negative 3 dx. And again, you can use this formula here. Therefore, it's going to be x to the power of negative 2 over negative 2 plus c, or negative 1 over 2x squared plus c. Let's have one more example and then we'll finish this brief lesson. So x squared minus 2 over square root of x dx. Obviously this function can't be found in the table of integrals, therefore we need to make some changes here. So it could be this. And let's distributive law to get x2, x negative 1/2, negative 2x to the power of negative half dx. And as you know, when the bases are the same, you're going to add the exponents, therefore. So it's going to be 3 over 2 minus 2 to the power of 2x to the power of negative 1/2 dx. Now we are set to use this one that I'm going to highlight here with yellow. one of the most important formulas for integration. So it's going to be x to the power of 5 over 2 over 5 over 2. 2 stays. X to the power of 1/2 over 1/2 plus c. And the final step would be 2 over 5 x to the power of 5 over 2 minus 4 x to the power of 1/2 plus c.